Hi, nice to meet you. My name is Leonid, and I'm going to present you a little bit about what we do with Kotlin at Payworks. Before I do that, I want to ask you, how many of you are using the multi-platform in production? Like not playing around, but actually using. One? Nice. 1%. Great. We also do. We're two of us. So, what I want to talk about today... Wait, wrong button. This one. I'll do a little bit of introductions about me, about the company, and about the architecture, why we went to this solution, why it works for us. Then I will show you how we actually added the multi-platform part, and then a little bit of code examples. And at the end is what we plan to do in the future, right? So, about me a little bit. So I'm developing for 7 years already. I'm mainly an iOS developer, and now I'm a tech lead at the project I'm talking about right now. About Payworks, if you ask a salesperson what Payworks does, Payworks provides payment technology for the point of sale. Yay, I don't know what this means. That's why when people ask me, so what do you do at Payworks, I usually try to tell them something around the lines that, well, we enable stores and restaurants to accept transactions with cards and using only several lines of code. Even though it has like words which everybody knows, I think we need an example. But for example, I would need a little bit of imagination, yeah? So I want you, first of all, to imagine that I have really good skills of removing the white background from random images found on the internet. Now, imagine this. So it's morning. You go to your favorite canteen, and you want to take a soup because you feel sick. And then the lady says, and you say, the lovely lady says, you come with soup, like, yeah, it costs this much. And at that point, when you're talking to the lady, so it's a sale is coming on, commencing, right? So that we call point of sale, and shortly, POS. And then, so she types in just 1, 2 buttons for your soup, and a number appears on the display. So this is how much you have to pay. And you say, I want to pay with card. So, that by the way is a POS system, I forgot. I don't know the slides. And so you say, I want to pay with a card. So the lady clicks one more button, and that's it. And then on the small thingy, on the terminal, appears a number with the same amount you have to pay. And this, by the way, is a POS terminal. Here we have like an older POS system. Now they have this newer, fancy stuff, which it more or less looks like an iPad with some application. And they'll have all these fancy buttons. I want to show you an example of like a real client. So this is an order board. They work for restaurants. So they have all these buttons with, I don't know, it's customly made for restaurants so that they can sell as easy as they can do. And this is what they do. And they're not interested in the part with payment because it's hard. It's a lot of code. You have to do certification. It's expensive. So this is where we come in, right? So we provide them a small piece of software. They just click one button, and they connect to the terminal, talk to the backend, and everything happens without them knowing because they don't care about this. They want to provide, they have a different business, right? This is what we want to do. So we want to provide a piece of software, a package, which connects to a terminal, and of course goes to backend. But for today, we're going to focus on this part, right? We write something that first of all connects to a terminal and drives a transaction. And because we want to give our clients like more flexibility, I mean, someone likes a bigger terminal, like the one in this actual canteen. Someone is a merchant on the side of the road, and they want a smaller one. That's why we want our SDK should support several of these terminals. Now, Payworks is also 7 years old, so we're doing this for 7 years. And if you remember, 7 years ago, Swift, if you have iOS developers, was not yet public, if it existed. Android was only halfway through the alphabet. I still used to go to a hairdresser. And everybody of us who developed at the time actually cared how much our app weighs, how big it is, right? So it made total sense for us to actually have a piece of code which has all the business logic, which is absolutely abstract. And then for each terminal inside, you have a smaller piece of code that, I can do this. Wait a second. Nice. So for each terminal, you have a smaller piece of software. And if you want to use the lila one, you have this piece, and then the white one, you have this piece and this piece. Beautiful. And we have to do this twice, once for iOS and one for Android. Now I'm going to go a little bit more technical about this, how this used to look or still looks in an architectural level. So this is how we have it. So we have one repository for iOS, where is the business logic, and we have one repository for Android, right? And we actually have one abstract class here, and all the code which is inside here should talk with this specific abstract class. And then we have a different repository for terminal A, terminal B, and the same is done on Android. So now we want to add another terminal. What should we do? Well, if we go the same way, we would have chosen to have one here and one here, but we don't want to do this. And 7 years ago, we looked into C++, into code transpiling from Java to Objective-C, and all these tools were still rude, and like not rude, but rudimentary. And I said, okay, 7 years have passed, let's try one more time. So I still looked at C++, and I knew that I'm going to have to work with J and I. And for a simple method, where you have a class which calls something, you would have these long functions, and it's ugly. And we have classes with classes or packages in packages, and it'll. Anyways, I went to meet a friend who actually did this, to talk with him, get a little bit of insight, ask him how was his feeling about this, and he said that after he told me that, yeah, it works, it's bad, try Kotlin native. And I, of course, was like, what with what? Because I was an iOS developer. So I went home, not home, to work, back to work. I looked at Kotlin native, which was, at that moment was version 0.7, and I tried it out. I tried to see how the enums look, how the interfaces look, and I liked it. And while I was playing around and doing some other work in between, they jumped from version 0.6 to 0.7, which was for me neck-breaking. I understood, okay, these guys are serious. By the time we actually integrate everything into our project, it will be way better. And well, this more or less was the deal. So we decided this part we're going to do as in Kotlin native. And it should integrate into the Objective-C side and Android side. So now I'm going to go a little bit more technically with classes, and I need more space for this, right? So remove what we don't need right now. We have two bases. We have, of course, they're bigger, and there are actually a lot of other code here, which calls these two specific classes. It's important because this is where we have to plug in. When we add a new terminal, we have to inherit from this one. Great. So now we have to add another class for terminal C, which should inherit from this one and inherit from this one and be in both platforms. But as anybody did SDKs on two different platforms, we know that they're never the same. And there's never like feature parity. There's also like, they're almost the same, and I think it's even worse. So we said, okay, we want to do this, but this is experimental. It's still experimental, it's dangerous. We want to try to put it in. How we do? Well, one principle is we don't touch anything here. So the existing code should, hey, no, oops. Oh, sorry. So the existing code should not be touched. It should not know about Kotlin. It stays as it existed. So here's the class. So we add more projects. So we have a multi-platform project, and then we have wrappers. So a code which knows about this one and actually inherits from this one. So in Android, for example, they would know that it exists this class which inherits from here, and it can work with it. It knows, great. But this one actually just wraps a Kotlin part. And whenever we ask something from an abstract terminal, it actually goes to a wrapper. And then this one just forwards the request to the actual implementation. We have some other classes. So for example, we have a transaction object. So how it works is that this a lot of code creates a transaction, and it sends to the terminal to do something with it, like start transaction or cancel transaction, do something with it. So what happens is that this transaction object goes here and should work with this code. And then this code should also work with this one, which is the same transaction, but it's a little bit different. For example, here it has a flags field, and it's a bit field. And here is an enum set. Pretty hard to work with it. What we do? Yes, we do an interface, because interfaces are cool, and interface programming is the whole grail. And to make so inside here, we only know about something that implements interface of transaction. And how we make it work with what we have? Yeah, we add more wrappers. So we have one transaction. So we have a transaction wrapper for Android, which actually just wraps around transaction. And whenever we ask something from transaction, it actually asks something from here. And to give a nicer example, let's say we have a card data. So a transaction has a card data. Great. Two different card data, which are the same but not the same, but different. And we add more wrappers and another interface. So what happens is, for example, here we say transaction, give me card data. What actually happens is we go to the wrapper. The wrapper gets the actual card data from transaction, creates a wrapper, wraps it in this one, and the wrapper implements this interface and sends it in. And here, we don't know. It's something that implements this interface, and it works. And it works from both ways, there and there. And with card data is also interesting because sometimes if transaction we just use, card data we have to build, to create. And this is a nice place for more interfaces, wrappers, and builders. So what we have? We know we have something that implements this interface, that creates us something that has this interface. And what happens is we say, hey, something which is a builder, build. And the builder says, OK, creates a proper card data, wraps it in a wrapper, and gives us back. This is more or less how it works. And all of this, how we know about them, for example, the builder, is we have usually some global variables. So we just went the easy way, we experiment, and we try it out. On the project level, as proper files, how it looks, so we have 3 repositories, right? So this is like a repository for iOS, a repository for Android, a repository for the common part in Kotlin. And this part is submodule in these ones. So for example, shortly about iOS, so we have the core, we have this, which depends on the core, and then it actually wraps everything here. So here we have some build scripts, some specific build Gradle specifically for the native part. And here we have one single project, but in modules. And we have some build Gradle files, which are specific for Android. And how do we work? Well, I personally check out this repository, write the code in, check out this submodule, write the code, push it, commit it, push it, come to this project, initiate the submodule, and I have the latest code there, and I work. So it's a little bit of a lot of code. Now the question is it worth it? Did we actually reuse stuff? Did we actually wrote less code? So this is the actual data from this specific reader. The common part, which was Kotlin native, which was actually reused on both platforms, was 80%. And everything specific to the platform, this being, for example, for Android, the Java side, which actually was Kotlin, but it's wrappers, plus code in the multi-platform, which was specific to this, right? So for us, it works. But now the other question, OK, but is it less code than what we used to have? So I ran the same part with other terminals, and this is what we have. So with 2 other terminals, it's somewhere like this. So we have around 10,000 lines of code for iOS and 12 for Android. Here we have more. I guess here we have more features, because I said when you have 2 platforms, it's kind of hard to have the same functional parity. Great, so it worked. The numbers are cool. Now you may wonder, OK, but how it actually looks? So here I have a little bit of samples, and I have a little bit of map. So this, for example, means that it's here, and it's specific to card data kind of object, it's like a principal. And this is also card data, but in Android. And then there will be code in here or in wrappers. Look at the map. So this is actually, we have maxwrap information. It's basically card data. And in iOS, well, it's MP, because this is how iOS does. And here is maxwrap. Will be a little bit harder to put them together. And they all have just a string, which is mass track 2. Track 2, if you wonder what it is, if you get your credit cards, you have like a black magnetic stripe. So that's basically that binary data which is there. It's like this long, not amount, the data. So we have this. We have to work with this, and we have to write something here that works with both of these at the same time. And we thought, OK, how it should look in Kotlin? Well, we have an interface, which is maxwrap interface, and it has a mass track 2. And we also define, well, we can also build one. So we need something that builds something from a track 2 and returns something that has this interface. Great. And this is actual implementation in the Java project, or Kotlin. I call it Java, but it's Android. It's also Kotlin. So, oops. The types are type-aligned so that it's easy, because they're like kind of long to make them clear. So we have a maxwrap information W wrapper, which is constructed to use a JVM XWrap information. This is what we saw a little bit before. And this wrapper implements the common maxwrap information. This is what we saw one slide before, right? And this is the interface. We have a string with track2. What happens when we need a track2? Well, we get it from the wrap JVM class and we return it back. Exactly the same thing happens for Objective-C. And for the builder, well, it's more code, but it's also quite easy. So you have a builder which implements this common interface, and we can build something from track2. And what we do, we actually create an actual Android interface, and we wrap it, and this is function wrap. And we actually create a wrapper, and we return it. So internally, we always work with some interfaces which implement this, and it could happen, like actually, it could have come to two different places. So this is the builder, just a global variable. Because for now, it works for us, and we initialize it once during runtime. And we say, OK, so this is my builder. I have a dummy. I put dummy because I really don't like having these exclamation marks or question mark everywhere in the code. And this is why when we run first time, we have a nice message like, dummy, you should implement this in actual code. So if you implement it for Android and run it for iOS, we will not forget it to put there. And we will know what happened at runtime, but we test. So, so here is, for example, also so all this happens also in the wrapper code, right? Here, right? So we say we have a function which is called once per runtime because it's a companion object, and we have a different kind of like actual builders, and we set up for different variables. And whenever we need something, we just call that specific something. So another example now a little bit more complex. Now we want to call something on our call. So we have two interfaces, and this is like also actual code. One is for Android, one is for iOS. In one case, we have an enum set, and again, hey, OK. No. It's the first time. So once we have an enum set, another case we have a bit flag. Here we have a listener. Here we have just 3 callbacks. But the listener actually has the same callbacks. So now we thought, OK, how would this look in our Kotlin code? So it should something like this. We want to use suspending stuff to suspend. So we have another set of interfaces, and we return a result, which is a sealed class, because sealed classes are also cool. And then we have like, it could be success with what card type we detected. It could be we inserted, by the way, or we swiped if we just. And then we can say like, this is also a sealed class for the win. Or it could be cancelled for any reason. The shopper said like no, or the merchant said no, anyways. Or it can fail with an error. OK, so now we have to fix this one with 2 things there. Where we go? To the wrappers. Yeah, one more thing. Because suspendable functions can't be called from JVM like directly, we had to, and for Objective-C, we have our coroutine. So this is like a temporary function, which kind of looks like Objective-C. And we launch a coroutine, we do the detection, and based on the result, we execute the proper callback. So this should be used from iOS and from Objective-C, Android, I'm sorry. This is a bit of Objective-C. I hope you can read it. If not, I'll tell you. So what happens is that the interface we saw before, what we do? Well, we run on the same shared thread, because right now it's Kotlin multiplatform is 1 thread only. And we say, well, in the wrap module, call this function we just saw before. And then when we have, for example, that all the transformation from one kind to a different kind, right? For example, we have the same maxwrap information we saw earlier. So now, well, we know it's a wrapper, and we can unwrap whatever that is. That is something that implements this interface. But we all know that this interface is actually a wrapper, so we just shamelessly cast to there and take it back. So this is how it looks on Android. It should be more readable. We basically have the detect card. The interfaces we change to multi-platform. It's a map. And then the same. So we just unwrap what we have there. So because we know what's inside, we just cast it. So this is what for our specific code, and this is how we adapted this to one another. So we need the date. What we need from a date? Nothing. We just need the date. And then we needed something that is a date, and then we need a formatter that you give a format, and then you can create a string from a date, or you create a date from a string. That's all we need. This is all we defined in the multi-platform. The map disappeared. How it looks. So in the multi-platform, we have an actual. So this is a JVM. So now we have an actual date, which takes as a parameter a JVM date, and then we just initialize. And JVM date is just typalized to Java date. And the date formatter, we just wrap around a simple formatter, and we just forward everything to that class, and then we return it back. And on iOS, we have the same. So this is like an iOS main. We just wrap around an NSDate, and we use an NSDate formatter. It's red because we have just updated the Kotlin plugin, and it broke. It was building, it's building, but the IDE is not working. So this was another niceness which you have to work with when doing this kind of stuff. Okay, so was it hard for us? Yes. Was it work for us? Yes. Will we do it again? Yes, and not more. We want to move everything to Kotlin multi-platform. So this is what we want to do. So let's go back to where we were. So this is what we have. We have, one more time, this is one project. This is another project. This is one repository. This is another repository. And this is a third repository. So the first part we thought, this is how we think we should move towards one single goal. Move everything, both of them, to one single repository, all three of them. So then we will be able to actually create one Kotlin multi-platform project. The Android stuff is easy. We just move them around. The iOS should be rewritten. If you have students who are bored, apply. OK, so we will rewrite it. We'll have one single project here, which depends on two projects here. And we create two different, one jar file or several jar files and some framework files. And the next step for us would be probably creating another project, because we just cut two projects, we want to create one more back. And this project will be just interfaces. And everything will be we move like dependency from these dependencies. So for example, for MaxStripe, we'll move the interface separately, and we'll make on both parts the MaxStripe to implement that interface. And we'll start kind of moving these changes throughout all of here, doing a lot of refactor, crying a little bit on the way. Why we're doing it, I don't know, until everything complies to this interface and is used only that interface. Let's clean up a little bit. Yeah, of course, when you have this, and here, because we use the same interfaces, we don't need the builders anymore. So it will be a nice work for iOS to just rewrite it temporarily. If we clean up, it looks like this. So we have one point of truth with only interfaces, and then everything should depend from this one, and then this one also depends here. There is an arrow. I hope you can see. And this should be easy, because here is just like interfaces. Here we have like actual code we should move, and that might be a little bit more painful. But when we do this refactor and we move some of that code here, we could actually move some of the implementation, like more and more implementations here. Because behave. Because here we're also using the Okay, so here we'll also be using these implementations, but also as interfaces. So then we can just move all implementations to one single point, and we'll actually be using not only the interfaces, but some of the implementations. Most of them, as you saw, are like Pojo, so should be not that complicated. But this is how we envision. Maybe we're wrong. By the way, here's a lot of code. And then this a lot of code, and this a lot of code will be actually slowly, file by file, class by class, moving here, painstakingly refactoring everything until we have this. And here is how we see one single repository, and then we have our terminal and it works. What about other terminals which you already have? Well, because while doing this refactor, this will somehow get down to them. So we should be able to just use what we have already for them. Will we rewrite them also? Let's see. I hope not. But maybe by that time they're obsolete. Otherwise, we can also change them. And thank you very much.